To bring an app or product like this to life, we start by leveraging GitLab planning capabilities. Here, we can see how the organization building the application can organize itself by using groups and subgroups. These represent different teams working on different projects with its respective source code. As an example, here we have the codebase for the mobile developers and the different projects they are working on. And how are teams doing the planning, building new features, or managing defects? My product organization has the work organized in epics. This team has been working on large features that involve multiple discussions in different issues and projects. We use epics to consolidate those issues and track work. In addition to that, we have a roadmap view, which allows us to visualize milestones and the progress of the work being done and its completion percentage in a form of a timeline. This is helpful for leadership to get an overview of what's being completed and how far we are along that process. Now, let's take a look at labels. This allows me to answer the question of who is working on what in the organization and set up workflows and boards. There are different fronts needed to build a product like this, and the labels help us to find out which part of the product someone is working on. Alright, since we have planned it, let's get some work done. Going back to the issue boards, we can see here what it's in the backlog, or switch boards and see the workload distribution in the team. I am at overcapacity right now. My limit has been set at 3 items and I have 4. You can also tell by my red background. I will pass one of my issues to Cesar. And now that the red is gone, I will focus in getting this issue about feature flags closed. Let's take a look at this issue to enable feature flags in my application. First, the issue contains tasks. These tasks are a breakdown of the necessary steps to be executed to consider this issue done. It has linked items, which establish a relationship between this issue and other work being done in my project. I better close this issue soon, since I can see it's blocking other work in the project. From here, we can also learn the hierarchy. This issue belongs to this epic. This epic groups all the different issues in different projects that aim for a common goal. In this case, to implement continuous delivery and release orchestration in my application. This issue also belongs to this milestone. This milestone has been defined to track releases. It tracks all the issues and MRs towards release 1.0. Burn up and burn down charts show us the progress of completing this milestone. And additionally, this issue is part of an iteration, which is where we define smaller timeframes. And as you can see here, I have to work on this issue during this iteration. Alright, let's create a merge request to add the work that needs to be done to enable feature flags. This merge request is automatically associated with the open issue I'm working on. When the work is done, as stated in the description, it will close this issue and reflect this in the status of our iteration and milestone. Alright, I have created a merge request, added a reviewer. Now, I want to use the web IDE to add the instrumentation needed in my application to enable feature flags. Using the web IDE, I can see in line 321, I have the feature I want to put behind a feature flag, which is a data panel that allows me to add a hashtag and get a predicted emotion with respect to a tweet. I commit the changes, and this will automatically trigger my CI pipeline, build my container image, scan containers, scan dependencies, code quality, SAST, and secret detection, right in the merge request. Additionally, I can start a code review, asking Cesar to review the lines of code I just added. When the pipeline is done, we get a full report of the impact of this merge request, from code quality to security vulnerabilities. We will go deeper in the GitLab security features in the next chapter of this story. At the moment, let's take a look at the pipeline executed for this merge request. We see all the security scans, including Dust, and let's bring our attention to the QA environment. As a platform engineer, I have defined the deployment of this environment as a manual job. Let's click on it to deploy it. Besides, this is the environment we need to test our feature flags configuration. Now, under deployments, we find the option to define feature flags. Let's choose a strategy, since we already instrumented the application script. We see we can link the issue we are working on right now to the feature flags view. Alright, I want to use a %rollout strategy based on a random method and set 50 as a percentage. Down here, we see staging is the environment scope for this feature, which is the one we just deployed when we manually deployed QA. I save these changes and let's see it in action. Under deployments and environments, I get quick access to the staging environment or QA we want to use to test our feature flag. This is my staging environment. Remember, we set a percent rollout of 50% and a random method. We can see here the predicted emotions data panel. This is what we put behind a feature flag. Let's try refreshing the app again. Now we don't see it. One more time. Here it is. One last. And it's gone again. The feature is off for this attempt. I think this little test is enough. We have seen how we can toggle a feature on and off. This helps us to do control testing, reduce risk, and achieve continuous delivery. And I have configured all of this without leaving the GitLab DevSecOps platform UI. Going back to the issue, I can declare these tasks completed. Good, I did this on time. This issue has a richer view now, showing us the related merge request that will close it and the related feature flag that it was affecting. All of this help us to, at any point in time, get visibility of the work being done across different teams. We are quite close to finish our mission here. Going back to the merge request, I can see a full report of the impact these code changes will make to the application. We see it needs to go through some deployment approvals, code coverage, and as a platform engineer, I have set up code owners associated to a file. The reports are giving me code quality suggestions. This shows me good candidates for refactoring and improve my development skills. For demo purposes, let's pass on this and focus in the critical security vulnerabilities. One of my scanners detected this vulnerability in one of the dependencies. From here, I can create an issue to investigate this vulnerability and of course, involve the security folks from my organization to help out. In this case, the scanner is also providing me with a solution. Therefore, I will go and grab the latest version of this dependency that has been flagged as vulnerable. Having this, I can update my pip file where I manage my project dependencies, and I have also changed the Docker image to a different one with less vulnerabilities. When I apply all the changes and the pipeline is done, I can see here in the merge request all the additional commits that I have worked to fix the errors, providing full visibility of all the work that is being done in this MR before it gets merged. I can see that the critical vulnerability found in the dependency with the dependency scanner is gone, and the new image reduced the amount of vulnerabilities found in the container. Let's assume we are good to go, so we can see the next stage of my deployment. So I provide the respective approvals, the deployment approval, coverage check, and code owners. I resolve the threats from the collaboration with Cesar. And this is ready to merge. Before merging, let's take a closer look at what it says here. This is telling us that this merge request will close issue 42, which is the issue we have been working together all along. Let's merge the changes. As a platform engineer, when developers merge changes to the main branch, this will automatically trigger a pipeline to production, following in this case a GitOps pattern. Let's dig deeper into that. This is our path to production pipeline I have configured. As a platform engineer, I wanted to make sure to isolate the application building from its deployment, so developers can focus in a single project, while platform engineers can focus in the deployment one. Of course, this is invisible for end users, thanks to this multi-project pipeline that you can see here. This pipeline has finished. Let's go through the steps it executed. Our application container was built again. This is the container production image. And the application was tested by security scanners. Remember, these security scans always happened because they are coming from our compliance pipeline that we saw in the major use cases. And the third stage from this pipeline is a trigger to the deployment project. Now, going to the project in charge of deployment, the one that is independent from the building app, we will find that the triggered multi-project pipeline modified the Helm manifest files. Let's open the manifest and check its commit history. Here we see that this was done by the pipeline, and the tag of the image built in the previous project was commit here. And how did that happen? This happened thanks to the agent for Kubernetes. GitLab DevSecOps platform can natively integrate with a Kubernetes cluster using this agent. Under infrastructure and Kubernetes clusters, we can see the integration here. Here is the agent and the connection status with the cluster. To implement this agent, we have created a directory for it and specified in a config file the path it should read for changes in the manifest files in this repository, since the files, of course, are under version control here. So whenever we update the image and automatically trigger the release of a new production app, as a platform engineer, I have configured the pipeline to update my release pages, showing me the binaries and version of our latest release here. Alright, let's finish our deployment mission. It was an easy mission, thanks to all the automation that as a platform engineer I have configured. By checking the environments page, here I can manage different environments where my app has been deployed. Let's open the production environment. And here it is. This is the app that GitLab DevSecOps platform helps us to build, test, secure, and deploy. Using GitLab DevSecOps platform, as you could witness, building a feature and taking it all the way down to production with me, help us to increase operational efficiency while reducing security and compliance risk.